As shown in our previous video, the synapse is a gap between the terminal of a neuron and the dendrites of another neuron. This is where the electrical signal is translated into a chemical signal and how information flows from one neuron to the other. It's estimated we have 100 trillion of these synapses in the brain, and by understanding a synapse's ability to pass information through chemical neurotransmitters, we can understand how medicines as well as illicit drugs act upon our brains. So what does a synapse look like? Generally, a synapse has three major sections: the presynaptic terminal, the synaptic cleft, and the postsynaptic dendrite. The chemical communication happens all throughout this area. Everything you remember, do, or feel from being happy, confused, hungry, excited, depressed, tired, all come from neurotransmitters passing information through your synapses. Even while looking at this video, neurotransmitters are flowing between neurons in your brain in a continuous chemical conversation. Now, there are different kinds of neurotransmitters, but we'll get into more detail about that in the next episode. For the moment, let's imagine a generic neurotransmitter. This little guy is going to be very useful to explain the basic but complex notion of life as a neurotransmitter. Hello, transmitter. How's it going today? Ready to live your life? Yeah. Neurotransmission is made of 5 major steps: synthesis, storage, release, reception, and interruption.
Let's begin with synthesis.
Neurotransmitters are synthesized from precursor molecules and by enzymes inside the neuron.
Storage.
The neurotransmitter then gets stored into vesicles with the help of transporters, named vesicular transporters, that grab it and store it inside the vesicle. The vesicle full of neurotransmitters then binds to the inside of the terminal membrane with the help of proteins, and stays latent waiting for an action potential, also known as the signal to release.
And let's talk about release.
Once an action potential does come, the terminal is flooded with positively charged calcium ions, causing the vesicles to open and release the neurotransmitters into the synapse.
Reception.
Neurotransmitters rush to bind to their receptors, often located on the postsynaptic dendrite. In some cases, these receptors open in response to the transmitters and flood the postsynaptic dendrite with positively charged ions, causing the electrical signal to continue along in the next neuron. The signal has officially been passed.
Interruption.
Once all of this is done, it is very important to clean the synaptic cleft from these neurotransmitters to make way for the next transmission. In this way, the signal is stopped, or interrupted. There are 3 ways to remove neurotransmitters out of the synapse. One way is to simply do nothing and let the transmitters diffuse away. This is slow and inefficient, but does happen. A second way is enzymes. These enzymes break down the neurotransmitters into simpler chemical parts. The third and most clever way is through transporters. These very efficient vacuum cleaners are also known as reuptake sites. Thanks to them, the neurotransmitter is vacuumed back into the terminal and stored into vesicles and recycled. You may wonder why all these steps are so important. First of all, neurotransmission is the key language of the brain. This is where neurons talk to other neurons. And if drugs and medicines are able to manipulate this language, we can begin to see how they can either help its users or cause an unhealthy addiction. This is the subject of our next video. We will look at how certain medicines and drugs affect the synapse and their ability to heal or hijack your system. So please, stay tuned.